Okay, hi grade 12s. We're going to be working today on the oxidation reduction reaction that is a dry lab. And in chemistry, when we say a dry lab, actually in any science, when it's a dry lab, it just means that you're going to be given the data and then you're going to analyze the data and do some questions that follow up from that. Okay, this one's an activity that's way more fun if you work together with somebody. So in our distant learning model that we've got, if you could find a lab partner, that would be amazing. So jump on the Google Meet, and that's why I wanted you to do that so that you can work with somebody else. Keep the chat open and your Google Meet open so that if you have questions for me, I'll be able to answer them because you want to make sure you can get this activity done. This should only take you about 30, 35, 40 minutes probably to work with your lab partner. Okay, so let me set it up for you. Here's what would happen if we were doing this in the lab. You're going to be taking different metals, adding them to solutions that have metal ions available in them. So basically respective nitrate solutions, because the nitrate's not going to do any factoring into the reaction. And then you're going to be seeing, based on the fact that the observations tell you whether the reaction occurred or not, you're going to be writing up the net ionic equation for the reactions that did occur. And then you're going to be comparing these to see which ones are stronger than others based on the fact that if the reaction did occur, then you know which metal got oxidized and which ions got reduced. Okay, all right, so basically you're taking strips of metals. So imagine I've got zinc, lead, and copper, and we've just got these little tiny rectangle strips, and we would sand them down to get rid of any of the oxide coating that's on them. So we've got pure metals. Then you're going to put them into the different nitrate solutions. So for the first one, here's my metal. And here is my nitrate solution, a 0.1 mole per liter solution. So when you're picturing this, you're picturing the fact that you've got lead nitrate in that beaker. They are dissociated. You've got ions of lead available. The ions of nitrate are there and not doing anything. And then you stick a piece of metal that's zinc into that beaker. Does a reaction occur or not? So here's where you read what it shows you, the observations stated. So yes, the reaction occurs. A gray silver powder forms on the zinc that was immersed. I wonder which metal that is. Solution remains colorless. So because this reaction occurred, that means that my metal did get oxidized. It was zinc. My ions of lead did get reduced. And so now you can fill in your net ionic equation. Okay, so you're going to go ahead and fill these ones in. I'll do the first one for you. So our lead ions go from Pb2 plus aqueous to lead solid. And my zinc goes from zinc solid to Zn2 plus aqueous. Okay, that's my net ionic equation. Remember, you could put your oxidation numbers on there. You just have to basically think about what's happening here. Which one is getting oxidized? Which one is getting reduced? It tells you that in the equation and the observation. But remember, you could use the oxidation numbers to figure that out too, right? Leo, Ger, losing electrons is oxidation. The oxidation number, which way does it go? Up or down? It goes up, okay? Reduction is a gaining of electrons, so your oxidation number goes down. That brings in some of the work you worked on before. Okay, so observation number 2. For the reaction where you had zinc and copper nitrate, yeah, that reaction occurs. The copper comes out of the solution, changes from blue to a mint greeny color. All right, happens faster than the first one, so that's a good observation to make for that reaction. And because this reaction occurs, you can write the chemical equation. So you're going to write the net ionic equation for reaction number 2. Then you notice that zinc nitrate solution mixed with the lead, no reaction occurs. Okay, that's going to tell us about the strength of these ions and the metals in regards to comparing them with each other. Reaction number 3 does occur, and so you're going to have to fill in the net ionic equation for reaction 2 and 4. And then I want you to look at this information, and now you're going to analyze it. So this is where you're going to be working through the questions. Do this with your lab partner. Okay, note that if the question is asking you for the metallic ion, it's asking you for, right, Pb2 plus, Cu2 plus, Zn2 plus. Which ion is it? okay? Not asking you for the metal, it's asking you for the metallic ion because it's the ions that get reduced, okay? So you have to be very careful here when you're answering these questions. Is it telling you about the metals get oxidized, or is it telling you about which ions get reduced? Okay, so you're comparing the ones you see in the table for question number 1. When you move on to question B, it's going to give you one more set of information about an observation. It says if you put a strip of copper into a solution of silver nitrate, that's the demo that I've done, I did in the tutorial the other day, but I'll show you that observation again. It actually happens. The silver gets reduced, it comes out of the solution and produces silver sitting right on top of that copper wire or the copper strip. Okay, so then I want you to figure out then which of the metals gets oxidized, which ion gets reduced, and complete the net ionic equation for this reaction. Now, take the information from the data table and what you just realized about silver, and for 1C, you're going to write half reactions for the reduction of each metal ion in order of decreasing ease of reduction. So what's the half reaction for the metal ion reduction? Which one is the most easily reduced to the second, to the third, to the fourth? Okay, that is basically what you're summarizing. You're seeing which one is the most easily reduced ion, comparing the 4, the 3 from the table, and then throw in silver when you're comparing it silver to copper. Okay, all right, fill in the questions number 2, 3, 4 on page number 12, and you're going to be submitting that to the assignment folder. Okay, good luck, and stay on the Google Meet in case you have any questions for me. I can help to clarify. Okay, good luck.